If you like this video, please subscribe. Thank you. This podcast is about malonyl CoA, a very important intermediate in fatty acid synthesis and also a very important regulator of fatty acid beta-oxidation. Malonyl CoA is an essential molecule during fatty acid elongation, starting with acetyl-CoA. Malonyl CoA is the donor of the 2 carbons required or needed during fatty acid synthesis in the cytoplasm. Malonyl CoA is a 3-carbon acyl chain that is the substrate used by fatty acid synthase, which is responsible for the formation of palmitoyl CoA in the cytoplasm, starting with acetyl-CoA. However, every 2 carbons added in the elongation process are donated by malonyl CoA. The synthesis of malonyl CoA in the cytoplasm is the rate-limiting step in all of fatty acid synthesis, hence the importance of this step. It is catalyzed by the enzyme acetyl-CoA carboxylase, which adds a carboxylic group from bicarbonate to acetyl-CoA using energy from ATP and requiring the vitamin biotin. Acetyl-CoA carboxylase is therefore a very important enzyme, and its activity and regulation of its activity is quite important in determining the rate of overall fatty acid synthesis. This enzyme is regulated in 2 important ways, allosterically and by covalent modification. Allosterically, it is activated by citrate in the cytoplasm, in that citrate will promote the polymerization of acetyl-CoA subunits to form a much more active polymer of the enzyme. So the enzyme in the polymer or multiple subunit form is more active than the monomer form of the enzyme. As such, when citrate is elevated in the cytoplasm, it will activate acetyl-CoA carboxylase, and therefore fatty acid synthesis will be activated as well. Acetyl-CoA carboxylase is also allosterically inhibited by palmitoyl CoA. High levels of palmitoyl CoA or any long-chain fatty acid CoA in the cytoplasm will promote the depolymerization of the enzyme, meaning going from the multiple subunits of the enzyme to a monomer or a single subunit of the enzyme. In that form, acetyl-CoA carboxylase is no longer active. High levels of palmitoyl CoA in the cytoplasm will inhibit the activity of acetyl-CoA carboxylase by promoting the dissociation of the polymer into monomer, less active form of the enzyme. The second important regulation of acetyl-CoA carboxylase is that it can be covalently modified by AMP kinase, meaning it can be phosphorylated by AMP kinase. In the phosphorylated form, acetyl-CoA carboxylase is less active than the dephosphorylated form. As such, phosphorylation of acetyl-CoA carboxylase by AMP kinase will inhibit the enzyme and therefore inhibit fatty acid synthesis overall. Conversely, acetyl-CoA carboxylase is activated by dephosphorylation by a phosphoprotein phosphatase. So acetyl-CoA carboxylase, in summary, is activated either by high levels of citrate in the cytoplasm allosterically or covalently by dephosphorylation by phosphoprotein phosphatase in the cytoplasm. Under these former conditions, acetyl-CoA carboxylase will be activated and will promote the formation of malonyl-CoA, which serves as this important substrate for fatty acid synthase. And as a result, fatty acid synthesis will be activated or increased in the cytoplasm. It is noteworthy to remember that high levels of malonyl-CoA in the cytoplasm are indicative of ongoing fatty acid synthesis. Simultaneously, these high levels of malonyl-CoA in the cytoplasm will inhibit the transport of long-chain fatty acids to the mitochondria by carnitine palmitoyl-CoA transferase, or CPT1. Inhibition of CPT1 by malonyl-CoA will ensure that there is no fatty acid beta-oxidation taking place while fatty acid synthesis is underway. In the big picture, it is noteworthy to remember that fatty acid synthesis will occur during the well-fed state or when insulin is high. Under these conditions, citrate will be elevated in the cytoplasm, and insulin will promote the dephosphorylation of acetyl-CoA carboxylase. Both of these conditions will activate the enzyme and result in the increased synthesis of fatty acids in the cytoplasm. If you like this video, please subscribe. Thank you.